Hi, Mojotonians. We're back. This is Andy Johnson from Mojotone. We have got our 5E3 together in one piece. It looks like an amp, more or less. And now we're going to start the actual voltage test of the chassis itself after assembly. One thing I did before I started this was I went and I tested the continuity. I'm going to slide this over here so you can see the meter. The continuity of the actual chassis itself, and what that means is that I want to make sure that I have this ground here. I want to make sure that my grounds are all grounded. In fact, there we go. All right, and I can see my AC. I know my filter. Okay, center tap. Yeah, that's done. Okay, now I'm going to go through, and I'm not going to do the full thing because I've already done it. But what you want to do is you want to look at the actual wiring. For example, the last filter cap here, I know that this wire is our plate supply for our preamp tubes, so I'm going to make sure we have continuity there, here, and here. There we go. Okay, but you go through the whole amp like that just to make sure that when everything's in place. Of course, you do it before you put it in there, but it never hurts to second guess your work or to go back and check, even though it might look right. Check it anyway. Believe me, it can save you a whole lot of time down the road. All right. Okay, so we've got our cord in, we got everything ready to go. I have it plugged in. I have my fuse in here. All right, so we got that. Now what I'm going to do is, get the feet back in. There we go. Now what we're going to do is I want to test the voltage secondaries of our power transformer. We're absolutely sure nothing's touching. We're absolutely sure we've gone through and looked at all the pins to make sure nothing's bridged across or shorted together. Make sure everything is where it should be. And this is where it comes in handy to actually have a friend or two or somebody that's a little, electronically a little bit more savvy with this stuff. They can go over and just lay a fresh set of eyeballs on it. Make sure you haven't missed anything obvious, because when you start staring at things 15 times, you start to not see things. Things are not so obvious to you because you've already seen it. You've already checked it maybe 2 or 3 times, so you're not going to check it again. You're not going to look at it again. You keep going over the same thing, make sure it's right. Everything seems right. If that's the case, do yourself a favor, put it away for a day or two, then come back at it with a fresh set of eyes, and then you start back on the trouble or the continuity test, or just to make sure everything's right. Okay. You can never have too many eyeballs laying there looking at these things, just to make sure you're okay. Alright, so we have our fuse in. I've got my AC plugged in. Now I don't have any tubes plugged into this whatsoever, and at this point I do not need a speaker or a load plugged in, because all I am doing is I am testing the actual transformer secondaries. Okay, so what I'm going to do is try to get this on video good. I'm going to lean this up, okay, so you can see the tube sockets. And over here on my meter, I want to be on AC voltage, because all my transformer secondaries are AC, anywhere from 600 volts to 1,000 volts. Auto ranging is good. This one, however, is not auto ranging, but it's true RMS, which is really cool. All right, so I have my pilot light, so I know I have my 6.3. Okay, and I'm going to check that again down here. So if I haven't blown a fuse and I'm showing the same voltage at both spots, there we go, can't even probe in there. Okay, there we go. We know we're good. We know we're not shorted anywhere down the line. Now, if you notice, the voltage is 7.434, whatever that is. Okay, that's perfectly normal, because we do not have loaded voltage. We are not loading down the transformer whatsoever. And the power in my shop here, just for instance, I'm going to plug this and put the probes in my outlet here. And I'm running, well, if I get them in there. Get in there. There we go. I run almost 125 volts here, so that's going to elevate everything on my secondaries, and I need to be mindful of that when I'm, looking across the actual board itself. So that basically means that already, because the voltages are unloaded, they're going to be 10% higher than what they are. Then add an extra 1-2% because I'm about 5 to 6 volts over where I actually should be for 120 volts. And this is very common. We get a lot of calls about this, And when we get the rectifier in, it'll become even more obvious to you, and you'll see that. Okay. Now, be careful with where you're sticking your fingers in. Okay. I just did this to straighten out the cathode cap because I know where the voltages are at on this chassis right now. Okay. So first thing I'm going to do is I'm going to check, pins 4 and 6 are high voltage. And remember when we had the center tap here that's going to ground? Okay, that's our high voltage secondary. What we want to do is we can measure from wire to wire, but to make sure that to check the transformer and make sure that both sides of the high voltage coil are equal, I like to do both to ground. So I can actually hold this. So I'll go to ground to pin 4. All right, 410, and pin 6. Get this in here. Yep, right around the same. 409 point. Yep, very good. All right. Now, because the 5-volt filament for the rectifier doesn't have a center tap, a lot of people make this mistake too. They'll go from one pin to ground. They'll go from one pin to ground and say, okay, I got 5.9. That's normal for unloaded. But they'll go over here to this other one. It's nothing. It's like, oh, there's something wrong with the transformer. No, there's nothing wrong with the transformer because you don't need a ground reference. What you're doing is that you're measuring across the coil itself to start to finish to see what you got. And we should have the 5.7, 5.9, 6. Yep, there we go, 5.9. Okay, so that's normal, again, unloaded. And that's basically it for checking our secondaries on our transformer. The whole time we're doing this, we're listening to anything unusual, and we're also smelling to make sure that nothing has really started burning or anything like that. You have a short, because that will give it to you right off the bat. You'll smell it before you see it probably. Okay, so I'm going to turn amp off. Got some test tubes here. Test tubes. I got my tubes here that I test with. I know they're good. So rectifier. Okay. Now keep in mind, if you're building this on a bench and you have access to a variac, that's the way to go. But 99% of the builders out there don't have access to a variac. So this is the actual woodshed way, I think, on actually testing a tweed amp. Now I will note that the reason I'm putting the preamps in down here with the rectifier is because, don't forget, these are 475 volt caps right here, okay, which is more than enough for regular tweed operation. However, when it's unloaded and you have a rectifier in here, especially on modified 5E3s like a GZ34, your B plus is going to be pushing well over 520, even as high as 550 volts, and you don't want that unloaded because guess what? You'll blow one of these caps like a fuse. So that's why I add the 2 preamp tubes. They don't draw much power. They pull the current for the filament, so it's a little bit more safe on the circuit because it pulls the current down slightly, and you'll see a massive voltage drop once we get the 6V6s in here. Okay, so next I'm going to do, know that everything's okay. I don't need dummy load at this point. I'm going to turn it on and I'm going to wait, and what I want to see is that when we're looking at our tubes right off the bat, again, not smelling anything. I don't know if you can see this down here. It's kind of difficult to see, but there's actually 2 heaters in a 5Y3 rectifier. Actually, most full wave rectifiers have 2. You can't really see because of the light, but you'll notice that there's 2 filaments in there, and you'll see them, and they travel around the cathode up the plates. And I'm looking at the 12AX7s as well, and I have glow on both sides of those because, again, these are 2 tubes in one, so you have 2 filament circuits in these actual preamp tubes. You want to make sure you have glow on both sides. Okay, now for an example how much that actually brought down the voltage, slightly, I'll look again at our filament voltage here for the rectifier. It was 5 point, I don't remember what it was, to be honest with you. It was pretty high. Okay, so now we're down about 5.5 volts. And our 6.3 will also be down. It was up over 7 and I don't remember what it was, 7.2. But this has hay blower transformers are a little bit over engineered. The stock 5E3 transformer I think was good for maybe 2 amps on the filaments for the octals and the preamps, and it was drawing right at 2 amps, maybe a little over that, 2.5, but they were good transformers, of course, because there's certainly enough of those still in circulation today. But Haybauer, I believe the secondary current on this is up around 3.5, 4 amps. I think we have it listed at 3, but it's way up there. The reason we did that was because a lot of guys like to modify these and put 6L6s in, or they use the GZ34. So that's kind of why we do that. All right, so I've got our AC section out of the way. So from here on out, I'm going to be doing DC. All right. Try to get my light on here. Where's my light? Oh, my light's not on. Why is my light on? Anyway. Oh, jeez, wrong button. My battery must be going on. Anyway, I'm sure you can still see that there. Actually, let's slide this down a little bit. Okay, so we're going to be doing DC voltages. If you notice on my multimeter, I'm at 600 volts because the B plus is up there. It's going to be pushing close to 500 volts, even with the power being drawn down. Okay. So what I want to do is I only want to use one hand because, again, people, this is high voltage stuff here. Okay. And what I'm doing is I'm wedging the negative test probe in between the transformer and the chassis so I have a good ground, and I'm only using one hand and I'm not touching anything with this hand. So here we go. B plus is up around 530. Okay, that's a little high, but it'll drop way down. Okay, so I know we have voltage there, and I know we have good voltage there, and of course this is really way high. This is again, because of my wall voltage is slightly higher, it drives up things on the secondary. I won't say exponentially, but a considerable amount. There's an actual ratio for that, but I won't go into that here. So I know we're good. I don't smell anything. We haven't blown a fuse. We're good. 530 volts. So I don't want to run that for long, so I'm going to turn this off. Now what I'm going to do is I'm going to put my 6V6s in. Let's see here. And you know what? Make sure you get the keys right on this. I know it sounds very dumb and things like that, but you know what? I've had 3 people this week have amp problems because they put one tube in, they forced it in one particular direction, they turned it on, all of a sudden nothing works. One case it was kept blowing fuses, and I asked him if he had, if they had done that, if they made sure the pins were right. Yeah, I did. Well, one I broke off, but I'm sure it's in there right. And I told him to send me pictures of it, and when he sent a picture, one of the 6V6s was off one pin. And you can tell that, not necessarily here, but you can see the actual construction of the tube. If you have 2 matched tubes, of course, they're going to have the same construction, and one of them is not going to look like the other. And it happens a lot. Just the little simple things like that. Okay, on to the testing. Now, because I have my output tubes in, power tubes, my 6V6s, I want to have a load on this. And this is a 50 watt, you can see that. It's a 50 watt 8 ohm resistor I use for testing. We have these in the shop that are great. Okay, so I'm going to go ahead and insert that. I'm going to turn my amp on, make sure everything's right. That's good. Everything was good. On. Pilot light's on. Alright, I'm going to wait a couple seconds for the B plus to come up. Again, I'm going to lean this over a little bit. Alright, at this point, you'll be very careful where you stick your hands in this thing. Now, like I just said, all the voltages are going to be in DC because I'm reading the power output of the actual rectifier, and I want DC on my multimeter. I'm reading 600 volt scale on my multimeter, so you can see it. Now, along the bottom of our wiring diagram, if you notice these voltages here, run all the way down. These are our test voltages. This will give you 90% of all the information you need to know in case, to make sure that your amp is working correctly. There's other little things these voltages could be showing properly, but if there was a component issue, it'd be very hard to find with just a multimeter. You need an O-scope and some other LCR meter to figure out what's going on in the actual amp itself. But for the most part, these things are very easy to troubleshoot. Okay, so again, I've got my 6.3. You can see that in there. There you go. So on the base of the 6V6 is right above the black part, those two filaments, they're glowing, so I know we're good there. Now, for instance, I want to show you the filament voltage on this. After we get the 6V6s in, it draws it down slightly. Now, keep in mind, my voltage here is elevated, so it's going to be a little high, and that's totally normal. All right. Now I'm going to go back up to DC, and I expect this to be pushing right around 400. Yeah, right, a little over 400 volts because of my wall voltage here. All right, so let me get this wedge back in here. Now DC, you always reference your ground, which is your chassis, to do any type of measurements. And again, you're only using one hand. You want to be careful. All right, so I'm starting. Even though my cathode is right here for my 6V6s, I'm actually starting here. I'm looking at the B+. Okay, so we're 402. Yeah, that's about right. It's right around 5.7, maybe 7%, 5%. Straight down, 354. And I'll show you the voltages on this chart here. 354 here. I had 403 here. I'm going down to here, the third stage filtering. I have 257, and it is 252. So as you see, as you get down the line, it actually draws, the power draws all that down. Okay, so I'm just going right down the list. 19 volts, cathode. Yep, we are good. Let's see here. 53 volts, red, good. 200 volts, 198, right on. This will be around 170. Yep, 168. Cathode's low is like 1.4, 1.5. Yep, 1.3. There we go. 134, and this should be about the same. 131. Yep, and 2 volts. All right, good. So we have good voltages all the way across the board at this point. That tells you that everything seems to be functioning properly. You're smelling for things, you're looking for anything obvious, and you're also listening, because if you have a short somewhere in your power supply, if you have B+ going directly to ground, or you have a bad cap, you'll actually hear it before it blows. You'll hear it creak because it's starting to expand. The electrolyte actually in the cap will start to boil, and it expands in that gas, and it blows like a steam boiler, like a firecracker going off real quick. But when you hear that creaking, you'll hear it tick, 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 turn it off on it, turn it right off, and feel the top of the well, no, I can't say that. Don't stick your hand in there. Don't do that. But you'll actually, one of the caps will be heating up. You'll actually know which is the bad one. That doesn't mean it's a bad cap. That just means you have an issue in that circuit. Okay, so what I'm doing now is I'm leaving this on. I'm listening. I'm smelling. I'm feeling my resistor here. Make sure it's cold, and it is. And the reason I like to use a resistor instead of a speaker is because if you have the primaries backwards, and this is especially for single-ended amps, not push-pull like this is, what will happen if you have the two wires backwards, it'll start to go into an oscillation, basically feeding back on itself, and it runs away, and it's not controllable with the volume controls, any of that. The only way to get rid of it is turn it off, all of a sudden. But before you do that, it's going to scare the crap out of you, and you don't know what to do. That's what you do. The second you hear that start to ramp up, keep your finger on the power switch and switch it off. Not a problem. Just switch the two wires. If it's a single-ended amp, a lot of them have the red going to the board, the blue going to the tube. Swap those. In this case, I know that the red is a center tap, so we don't need to move that, but we do need to move the outer two coils, which is the blue and the brown. Swap those two, and 90% of the time that gets rid of that problem. Now, this brings us to the resistor. When you have a resistor in place, what that tells you when you feel it, if it's heating up, you've got a runaway oscillation, because the tubes are pumping out everything they can, and the current starts to build in the output transformer to the actual output jack, and you can feel that. This is cold, so I know we're good. I know we're not feeding back. All right, good. All right, got everything going. After this has been on for a couple hours, you'll notice your voltages are actually starting to drop a bit, like they already down to 400. 349, so yeah, we're coming down. 255, yeah, so we're almost right on the money for everything. Now, when we're looking at these voltages, and again, I've said this before in a prior video, if you build two of these things and you go through, and the voltages are off. Like you're reading, I got 400 here, but the one I just built was 395. What's going on here? I don't understand. Well, it has to do with component drift, or not component drift, but component tolerance. Caps are usually 5-10%. Some large ones are 20%, like the JJs, the big filter caps they use on Marshalls and the Princeton Reverb. If you notice, in this amp itself, it has a gold band, and that's 5%. Silver is 10%, and that's I believe that's the majority of what actually Fender used was 10%. And we're having to go back to that because we're having a very difficult time finding modern production resistors that are 10%. They're all getting bought up, or for carbon comps, they're all getting bought up. Okay, so realistically, 5% is great. 10% is cool too. But back on the subject, the reason they sound different is because you have component variances. A 56K could read as low as 54K or as high as 58K. Doesn't mean the resistor's bad. You're not building a precise amp, you're building a vintage amp, and that was one of the things that went into the character of these amps across the board. You can't get hung up on resistors that, like for this instance, it's a 22K. I just out of an example, I actually read that 22K, and it was a 21.7, and it's amazing the amount of calls that we have. It's they get a 22K, or they'll read every single resistor in their kit, and it's like, no, this is a 21.5, this won't work. And it's like, well, you're totally missing. It will work, and you're missing the entire scheme of the amp itself. It's not a hi-fi amp. It's a vintage tweed amp, and that's what they were. Actually, the components in the vintage tweed amps over 55, 60 years have drifted so much that you cannot replicate unless you physically go in and find a 5E3 that has 10,000 hours of playing on it. It's like the smoothest sounding 5E3 you've ever heard in your life. You would actually have to go through each and every resistor and each and every cap to see exactly what it is, what the actual value of it is. And if you were even to build an amp like that, I know this because I've done a lot of stuff with this, it's still not going to sound the same. It just doesn't. They just have their different characteristics. And it could be something as, the output transformer isn't exactly an 8 ohm output transformer. It could be a 7.6, or it could be an 8.2 power transformer. You're not feeding the rectifier, the 365 volts per side. You're only feeding it 349 per side, and so you can't get hung up on stuff like this. You just can't, because you'll drive yourself crazy. People with OCD have a problem with that. I kind of have a problem with that, but it's the way things are. It's just the way things are. And we love these amps, all these amps. We love them for their little quirks like that. So I can't say enough about that, and that's true with almost any amp or any guitar amp. Even on modern day ones, the SMD stuff, they'll claim to use 5% or 1%, which is drives the cost up a little bit. But again, a little bit different. So that's that. Now, if you notice I haven't put the knobs on yet, I always wait to put the knobs on to the very, very last thing, because I have a bad habit of flipping the chassis over or leaning it forward, and I'll scratch the knobs up, and I don't like doing that. So I'll put the knobs on. Now, after this, I've been talking for about 5 minutes or so. I'm going to turn this off. Resistor is cool. Okay. I'm going to pull that load out, and I'm going to add my speaker cable to see if I get any type of audio out of it, and I should, going by just the numbers and everything that's going on in the amp. Alright, so I'm going to turn this on, I'm going to turn the volumes down, I'm going to turn the tone, let's see, here we go. Now I'm going to add a little jumper cable just to get some noise there. I'm not playing a guitar yet, so I just want to make sure that all the input jacks are good. Alright. That's jack's good. That's the bright channel. Jack 2 is good. Alright, normal channel. Alright, we got noise there. And the last one. Yep, we got noise there. Now, the top inputs on the Deluxes, and it has to do with the four input fenders that have a layout like this, and I believe the Tweed Twin High Power has the jacks across. There will be one or two jacks that are attenuated slightly, and it has to do with the actual resistors that you put into on the jacks themselves. That's totally normal. On our Blackout Deluxe that we made by John Manning, which is an incredible amp, he kept the character of that, so you can actually have a high gain or more gain on one channel than you can the other, but he kept the configuration so it looks, you know, a lot like a Deluxe. So it's an incredible amp. But that is it. That is the basic test procedures. At this point, I'm going to leave it on, and it's going to sit up on the shelf for about 8 hours on. I want everything to be running and not overheating. I don't need to inject a signal into this. Not yet. But when we go to, you know, of course I will test it with a guitar after we get done with the break-in period. Okay? So that is it. That is the basic testing for the Mojotone 5E3 Deluxe. Very easy. All you need is a simple multimeter. You know, find yourself a resistive load. If you don't have a resistive load, you can use this speaker, 8 ohm, in this case for the 5E3. And that is it. Thank you guys for watching so much. If you have any questions, email me at tech@mojotone.com or ajohnson, ajohnson at mojotone.com, and I'll get back with you as soon as I possibly can. Okay?